Hello and welcome to your notes on enzymes. Last class we discussed macromolecules. Can you remember any of the macromolecules? Can you remember what they do? If you recall, there were 4 macromolecules, 3 of which you can find on a food label. The first one being carbohydrates. These give you quick energy. The next one being lipids, also called fats. These give you energy for later or long-term energy. The third you'll find on a nutrition label is protein. Protein has a lot of different functions, one of which being enzymes, the other being building muscle, and another being growing hair and nails. Today we are specifically focusing on the one function of protein called enzymes. Enzymes are one type of protein. We often like to compare enzymes to Pac-Man because enzymes look like this. They have a small indent in them. So, think of the chemical reactions in our bodies. Where might chemical reactions happen? If you can think all the way back to the first week of school when we learned about characteristics of life, you learned a term called metabolism. Metabolism is the summation of all the chemical reactions in our bodies. When you think metabolism, often people think about eating because that is one of the biggest reactions our body undergoes. So, metabolism and remember, metabolism, macromolecules and their monomers. Enzymes are a special type of protein. Specifically, they're a catalyst. A catalyst's job is to speed up chemical reactions. If enzymes are a type of protein, what are enzymes made of? I know that the monomer of proteins is an amino acid, which means that the monomer for enzymes is also an amino acid. So why do I care about enzymes? Why do I need to speed up the reactions in our body? Well, when we drink something like milk, the sugar in the milk needs to be digested or broken down into smaller molecules that we can use for energy. You eat the sugar in order to get the energy. However, this can be a very long process. Enzymes in your stomach help digest the sugar so you can get the energy faster. How it does this is the enzyme bond to the polymer in order to break it down. How does it do this? How do enzymes speed up reactions? Well, every reaction requires energy to get it started. But with an enzyme, the amount of energy that's required is a lot lower. We call this the activation energy. If you look at the graph on your screen, you can see that the activation energy with an enzyme is a lot smaller of a hill to climb than the activation energy without an enzyme. That is how enzymes are able to speed up reactions. So, what does letter A show? Is that activation energy with an enzyme or without an enzyme? If you answered without an enzyme, you are correct. That is a very large amount of energy that's required for the reaction to take place. It would take a long time to be able to climb that mountain. However, B is a very small hill. This is the activation energy with an enzyme. It does not take a lot of energy to climb that hill. Letter A is without an enzyme. Letter B is with an enzyme. It's a lot smaller. So let's talk about some vocabulary you're going to need to know to understand how enzymes function. Enzymes are helper proteins. So what they do is they bind to a substrate. The substrate is what goes in. The substrate fits perfectly in the enzyme's active site. This is a little part of the enzyme, kind of like a puzzle piece that fits with the substrate. Once they fit together, the enzyme can break the substrate apart into a product. The product is what comes out of the reaction. So, I likened enzymes earlier to a puzzle piece. However, people like to compare enzymes to locks in that they're very specific. Only one specific key can open a specific lock. This means that one enzyme cannot work to break down all things. It only fits with one substrate. We call this the lock and key model. So, take a look at this enzyme. Which one of these substrates do you think is the perfect fit for this enzyme? Is it A, B, C, D, or E? If you answered C, you are correct. Substrate C would be able to fit perfectly in the active site, whereas the other ones would not be able to fit in the active site. Therefore, they would not work. Now, enzymes are super important in order to do work in our bodies. However, just like us, enzymes have an ideal temperature and pH that allow them to work. If it's too hot or too cold, or too acidic or too basic, the enzyme will denature. Denature means that the enzyme loses its shape and it will no longer be able to bind to the substrate. If an enzyme works best in an acidic environment, what do you think the pH the enzyme likes is? Hint, the pH scale ranges from 1 to 14. Acids are small numbers, so an enzyme that likes an acidic environment is going to like pHs below 7. When enzymes lose their shape, they lose their function, because their shape is what allows them to bind to the substrate. If the shape no longer fits, they can't do their job. Think about how if I were to melt a key, it's no longer going to open the lock. So, think about other things in our life that are going to be affected by their structure. If I were to melt a water bottle, is it still able to hold water? If I were to melt a phone, is it still able to make calls? Think about your teeth. If you were to rot your teeth with soda, would they still be able to chew food? No. These are 3 examples of how structure affects function. So, true or false? If there were no enzymes in your body, food would be broken down more slowly. Think about what enzymes do. Enzymes speed up reactions. So without enzymes, things would go more slowly. So this is true.